NFA. And for DFA, there are two rules. The two conditions must be satisfied. That is, every state must be defined for every input. And second one, at every state for every input, it must have only one output state. Okay, do you remember this one? Now, every DFA is also NFA, but every NFA is not DFA. But for every NFA, we can construct an equivalent DFA. So that conversion we do now. Is my voice audible to you? Hello? Please respond, anybody?
Yes, sir.
Yes,
Yes, sir.
Okay, thank you. Construct a DFA equivalent to the given NFA. Okay. Is this given automata NFA or DFA? Is this given automata NFA or DFA? Please tell me by looking. Hello?
Oh, NFA.
NFA.
Okay, please. Oh, good. Please maintain the punctuality. Already it is 10 minutes late. So actually the strength is 24, I think. Okay, tomorrow onwards, next class onwards, please maintain the punctuality. Okay. Why it is DFA? Why it is NFA? Because
Q0 has
in
two
Q0,
states in Q1.
yes, Q0 on input 1, it has multiple output states. So this is NFA. So for every NFA, we can construct an equivalent DFA. So here, present state, next state for input 0 and 1. So same inputs will be there in DFA also. Now, whatever the initial state in the given NFA, in DFA also will be the same initial state. So here simultaneously I will construct the diagram. So Q0 is the initial state. Okay. What is a DFA? Every state must be defined for every input. Okay. Come to this Q0. Q0 on 0 it has defined and it is having single output. So it is valid. So it is valid in the case of DFA. So Q0 on 0, it is Q0, it is defined for 0 and it is having single output. Now, come to Q0 on 1. Q0 on 1, it is defined but it is having multiple output states. But in the case of DFA, it must have single output state. Okay, for this reason, so Q0 on 1, we define for 1, but we will have only one state. Whereas Q0 on 1 in NFA, it is having two output states, but in DFA, Q0 on 1, we are going to only one state. So that is Q dash. Okay, Q0 on 1, Q dash. Okay. Here, the naming, instead of naming it as Q dash, to make the further construction easy, instead of Q dash, I will name like this. Look at this NFA, Q naught on 1, where it is going, Q naught on 1, it is in NFA, Q naught on 1, it is going to two output states, one is Q naught, the other one is Q1. So, but in Q naught, we are in DFA, this is the DFA, in Q naught on 1, we are going to a single state, but we named it as Q dash. So instead of naming it as Q dash, here in DFA, we will name that state as Q naught Q1. See, here in NFA, Q naught on 1, it is going to multiple output states. What states it is going to? It's going to Q naught and Q1. So I combined that name Q naught Q1. So Q naught on 1, it is going to Q naught Q1. Here it is a single state, but the name is Q naught Q1. Okay. So the advantage of that is the further construction will become easy. So Q naught on 1, Q naught Q1. It is a single state and name of the state is Q naught Q1. Okay. We have started from the initial state, and after that, whatever the states newly derived, we have to define for them only. What I mean to say is, in NFA, we will take the initial state only, this one, and we'll continue the construction. We need not to take every state in NFA, whatever the state given in NFA, we need not to take all of them. So we start from Q naught. What are the states we got here? One is Q naught. So for Q naught already we have defined Q naught on 0, Q naught on 1. The other state is Q naught Q1. So we must define for this state. This is the new state we got. See in the diagram. For this state already we have defined. So for this state we have to define for 0 and for input 1. Okay, now we'll go back. Here we must define for Q naught Q1 state. Q naught Q1 state for this state. This is the combination of the two states Q naught and Q1. So for this reason, we will go to NFA. This is Q naught and this is Q1. So we must define Q naught Q1 on 0. So for this reason, you go to NFA. So in NFA, Q naught on 0 is Q naught. Q1 on 0 is Q1. Okay, now I repeat, this is the state in DFA, the state is Q naught Q1. So this is the combination of Q naught and Q1 in NFA. So go to NFA, Q naught on 0 is Q naught, Q1 on 0 is Q1. So what is this combination for input 0? For input 0, the combination is Q naught Q1. So in DFA, if input 0 is applied for at the state Q naught Q1, it remains in the same state only. So in diagram, this one. Okay. Now we have defined for input 0. Okay. For Q naught Q1 state. Now we must define for input 1 also. Here for this input 1. Here. Okay. Again, this is the state of combination of Q naught Q1 in NFA. So go to NFA. Q naught on 1. These are the outputs. Q1 on 1. This is the output. So what is this combination of these states? The combination of these states is Q naught Q1. So in Q naught Q1 on input 1 in DFA, it remains in the same state only. Okay. So this is. And what is the new state we got here? There is no new state, only Q naught Q1. So Q naught Q1 on 0 is same and also on 1 same. So there is no new state. Here, if you observe in the NFA, in NFA we have Q1 state. But whereas in DFA, we don't have Q1 state. Now, what is the final state in the DFA? What is the final state in the DFA? In NFA, the final state is Q1, but Q1 is not present in the DFA. Then what will be the final state in DFA? Are you following? In NFA, the final state is Q1, but in DFA, we don't have Q1. Then what must be the final? The final state must be there now, as NFA is having. So the final states are those in the DFA containing the states Q1. I repeat, in the DFA, the final states will be those having Q1, because in NFA, Q1 is the final state. So which state is having Q1 in DFA? In DFA, the state having Q1 is this one. So this will be the final state and this will be the final. in diagram. So now look at this. If you observe this diagram, Q naught is different for 0 and also 1. Q naught on 0 single, Q naught on 1 single. In this state, on 0 single, on 1 single. Okay. So after converting this, after completing this construction, I can change the names. Naming is not at all important. So in the examination, instead of Q naught Q1, he can give you A and this is B. Just you see the structure on A at the state A on input 0, it is going to A. In the state A on input 1, it is going to B. So at A for 0, for 1, they are defined on 0 single, on 1 single. Again, at the state B for input 0, it is defined. At the state B for input 1 also it is defined. So B on 0 single, B on 1 also single. So it clearly this is the DFA. Okay. So copy this one. I'll give you one more. Any doubt? You please ask me.
So if the next state is not defined for an input, then
Yeah. Do you understand this question? Do you understand this construction, this conversion NFA DFA at this question?
yes, sir.
Okay, then leave it. I will give you one more question. After that, you can ask me if you still have doubts. Okay.
Okay, sir.
Shall I go for next one, students? Done. So one more thing. Sometimes I used to lose my internet connection. So please, if it is if there is interest in more than half minute, just anybody just call me to my number. I will check. So what happened is I continuously keep on giving the lecture without noticing the loss of internet. So please, if there is more than half minute, if you are not visible, if you are unable to see my screen, then call me to this number so that I can notice that. Okay, the interruption. Anybody? Okay, coming back. So did you copy this one? All. Shall we go forward? Okay. Next question. So try this one. Is this NFA or DFA? This is NFA because Q naught on 0, it is having multiple output states. Not only that, Q2 on 1 also it is having multiple output states. Not only that, Q2 has not defined for input 0. So here actually every state must be defined for every input in DFA, but Q2 has not defined for input 0. That is one drawback. And the Q naught on 0 and Q2 on 1, it is having multiple output states. So both the conditions are not satisfied here. So convert this into DFA. I'll give you 2 minutes of time. Okay. Just you consider the table. Table is enough. You need not to consider that diagram. So present state. Okay. Initial state is Q naught. So the same will be initial in DFA. Q naught on 0, we will go to Q naught Q1. It is single state. Okay. And Q naught on 1, it is Q2. Okay. Till now, do you have any doubt?
No, sir.
Okay. What are the states derived newly? Here, which state, the new state here, Q naught Q1 is a new state. So take that. Now, this is Q naught Q1. Come to this NFA. Q naught on 0 is this. Q1 on 0 is this. So, what is the combination of this for input 0 for Q naught Q1? The combination of these three is Q naught Q1 only. Okay. Next. Now Q naught Q1 for 1. Q naught on 1, Q2, Q1 on 1, Q1. So what is this combination? The combination will be Q1, Q2. Okay. Now. Now here the new state is Q1, Q2. I'm taking Q1, Q2. Q1, Q2. Q1, Q2. Q1 on 0, Q naught. And Q2 on 0, nothing. It is undefined. So what is the combination of these two? The combination of these two is Q naught only. Next. Q1, Q2 for input 1. Q1, Q2 for input 1. Q1 on input 1 is this. Q2 on input 1 is this. And what is the combination of these Q naught, Q1? Okay. Here, what is the new state derived? What is the new state derived? The new states are Q naught. Already we have defined here. And Q naught, Q1. This also we have defined here. So what is left? The left is this one, Q2. Q2 is also new state. We have to define for that state. So Q2, take the Q2. Q2 is undefined. Q2 is undefined for 0. But in DFA, we must define. Q2, even though it is undefined in NFA, we must define. Okay. So what shall we do? Anybody? Anybody? What shall I do here? Q2 is undefined for 0 in NFA, but in DFA we must define.
Maybe a dead state.
Very good. Excellent. So Q2 is undefined for 0, but in DFA we must define. So for that reason, we have to take a dead state. So you name that dead state as Q3 or Q4, any other state. But for easy identification, I am naming it as 5. It doesn't mean that you have to name it 5 only. So you can name it anything. Okay. So 5. Q2 on 1. Already it is defined. Q naught, Q1. Okay. Actually, guys, in Q2, if input 0 is given, we will go to dead state. This is the dead state, and dead state is also a member of this DFA. So every state must be defined for every input. So once we go to dead state, so dead on 0 is dead, and dead on 1 is also dead. So every state must be defined for every input. So that is the reason I am taking the dead state. So dead on 0 is dead, and dead on 1 is also dead now. So this is, we have defined at every state for every input. This is the complete DFA. Now, what is the final state in the NFA? The final state in the NFA is Q2. Then what will be the final states in the DFA? Whatever the states containing Q2, this is one, here Q2 is there, and this is. So these two are the final states. Copy this. Any doubt? Some girl has asked me some doubt. Now you please tell me, what is your doubt?
No, sir. Doubt is solved now.
Clear enough?
Yes, sir.
Okay, okay. So do you want one more example, or shall I go for different questions?
One more example.
Okay. Copied. So just observe here. This is the NFA. In NFA, we have two states, C Q0, Q1. And DFA, this is the DFA, this is the DFA, this one. And DFA also 1, 2, we have two states. So when we are converting NFA to DFA, the DFA may have equal number of states. Okay. And here NFA, we have 3 states. And the DFA, how many states we have here in DFA? 1, 2, 3, 4, 5, including that. That also you must count. So the DFA may have more. When NFA is having n states, DFA may have equal like this, or it may have more also. Okay. So I'll give you one more. Try this one. Go, welcome. Go. So done?
Yes.
Yes.
Yes, sir.
Okay. Q naught on 0, it is Q naught single only. Q naught on 1, Q1, Q2. Now the new state is Q1, Q2. Q1, Q2. Come to this, Q1 is undefined, Q2 is Q1. So what is the combination? Here Q1. The combination is Q1. And Q1, Q2. Q1, Q2 on 1 is Q naught, and Q1 on 1 is Q naught, Q2 on 1 is nothing. So what is this combination? The combination is Q naught. And now what is the new state? The new state is Q1. Q1 on 0, it is undefined. So when it is undefined, what must we take? Hello, what must we take?
Dead state.
Dead state.
Dead state.
Okay. Q1 on 0, already it is defined Q naught. Now, what is the new state here? The new state is dead. Dead only or anything else? And dead on 0 is dead, and dead on 1 is also dead. Okay. So I will change a little bit here. Just hold on. Okay. Till now, do you have any doubts in this conversion? Do you all got the same? And the final state is Q. Huh?
Yes.
Okay. This is the final state.
Yes, sir.
Everybody got the same?
Yes, sir.
Okay. I change a
Yes,
little
sir.
bit. And so before changing this, if anybody has any doubts, please ask me. Hello, if anybody has any doubts, please ask me. Any kind of doubt, no problem. Okay, I am changing this question a little bit. Here, Q1 on 1, the output is Q2. I changed a little bit. Q1 on 1, Q2. Okay, now I'll go from the starting. Q naught on 0 is Q naught, and Q naught on 1 is Q1, Q2. Okay, now Q1, Q2. Q1, Q2 on 0 is Q1. Yes or no? Q1, Q2. Come to Q1, Q2 here. Q1 on 0 is nothing, and Q2 on 0 is Q1. So common is Q1. Okay. Next Q1, Q2 on input 1. Q1 on 1 is Q2. Q2 on 1 is nothing. So what is the here? What is that? So is this Q2? సార్ నేను క్లాస్లో ఉన్నాను 10th కాల్ చేస్తాను సార్ నేను క్లాస్లో ఉన్నాను సార్ మళ్ళీ కాల్ చేస్తాను 10 తర్వాత ఓకే సో Q1 Q2 on input 1, Q1 Q2 on input 1, Q1 on 1 is this one, Q2 on input 1 is this one. The combination is Q2. That is I wrote here. So what is the new state? Now Q1 is the new state. Q1 on 0, it is undefined. That is the reason dead. Q1 on 1, again Q2. And what is the new state here? We have Q2. Now come to this. Q2 on 0 is Q1. Q2 on 1, it is undefined. So when it is undefined, what shall I take? When it is undefined, what shall I take? A dead state. Okay,
Dead.
already we took this dead state. So shall I take the same dead or shall I take another dead state? So in any DFA, there will be only one dead state. Okay, so 5, the same dead state we will take. And now 5 on 0 will be 5. And 5 on 1 also 5. So this is, now what is the final state here? Q2 is the final state. Then what will be the final state here? This is the final state and also this one. So nothing. I want to say, if here Q1 on 0 is undefined, Q2 on 0 is undefined. So here whatever the dead state we took and the same dead state we also will take. Okay. So this is. Now, is this enough? Is there any confusion? Or is there any doubt? Hello? Anybody?
No,
Huh?
No, sir.
No doubt? Okay. Next. The recognizability of NFA and DFA. The acceptability or recognizability of NFA and DFA in any language Tell me. Hello? Are you there?
Yes, sir.
Sir, B should be the answer, I think.
Which one?
Sir, B must be the same.
B is maybe same, na?
A must be the same. A must.
Others?
Must be same.
Okay. Listen. I'm taking one language L1, and for this L1, I have constructed an NFA. Means to accept every string of L1, I have constructed NFA. I didn't construct the DFA. Even I don't know whether there exists a DFA or not. Whether it exists or not, I don't know. Are you following? L1 is some language. I have constructed NFA. Okay, Pakka NFA is accepting every string of L1, but I didn't construct the DFA. Even I have not tried for DFA. Even I don't know whether there exists a DFA or not. You please tell me, will be there or maybe there?
It will be there, sir.
How?
We
What
can
is the
convert.
guarantee?
We can convert that NFA into DFA.
Very good. NFA already have given. Very good. Very good. Enough. I understood. Already I have given you NFA. Every NFA can be converted into DFA. So this NFA I will convert into DFA. So whatever the DFA we have constructed, these two are equal. Means and whatever NFA accepts, the DFA also accepts. Now this time, the next time, I took some other language L2. For this L2, I have constructed a DFA. L2 is a different language. I have constructed a DFA. I didn't construct NFA. You just tell me, will be there or maybe there or not? Will not be there.
It will
So
be there,
all
sir, because
DFAs are
every
NFA.
DFA is an NFA.
Very good. Every DFA is also NFA. So NFA is there. Now L3 is a different language. It is not at all possible to construct any NFA. Fix. You cannot construct any NFA to accept L3s. Then will be there a DFA?
No, sir.
Hello?
No, sir.
Why?
No.
Why? Because when NFA is not there, DFA is not there. Suppose DFA is there, example. If DFA is there, a DFA itself is NFA, but already we have decided that NFA is not possible. When NFA is not possible, DFA is not possible. But at the same time, if DFA is not possible, NFA is not possible. So if you observe all these languages, whatever the language you take, either they both accepted, both NFA and DFA accepting the language, or both are rejecting. So whatever the language you take, the acceptability of NFA and DFA will be the same. Means they both either accept or both reject. So any doubt? Hello?
No, sir.
The number of states of a DFA equivalent to NFA of N states is always more, always less, always has 2 to the power of N states, sometimes less number of states.
Option A, sir.
A.
A.
There is no option of equality.
It should be greater than or equal to.
Yes, sir.
Yes, sir.
Oh, no, don't change the option. Whatever the options I gave you the same. You just select one of them. So you mean to say E Nanna? E Nanna? Huh? Then you can go for this.
Yes, sir. None will be done.
See,
None.
we did the conversions. NFA, DFA. 3 questions we did. At least if you observe those 3, if you go back to those 3, you can answer these questions. You can solve this question. Okay. In the first NFA, we have 2 states. This is the first question. We have 2 states and DF is also 2. Here I wrote. Okay. And in the second one, in this NFA we have 3, whereas DFA we have 5. I wrote here. Okay. So in the first question NFA, we have 2 and DFA is also same. So always more is not at all correct. If always more is correct, when NF is having 2 states, the DFA should have 3 or more. Do you agree with this point? If this is the right answer, when NF is having 2, so the DFA must have 3 or more, but we have 2 equal. Hello, dear students, what do you say? Do you agree or not?
Yes, sir.
Now, if
Yes, sir.
always
Yes, sir.
if always this is correct, this and when NF is having 2, the DFA must have less. And the next question, we have 3 states and the equivalent DFA we have 5. If this is the second option is correct, the DFA should have 1 year and it should have less than 3, but it is 5 is not less than 3 and 2 is not less than 2. So this is not correct. Suppose this is correct. If this is correct, when NFA having 2, the DFA must have 2 power 2. When NFA having 3, the DFA must have 2 power 3. Is 2 equal to 2 power 2? Is 5 equal to 2 power 3? No, not at all. When ABC is not correct, then elimination process. D is the right answer. How this is possible, sir? We have seen this equivalent. Okay, more is also there. That is the reason we told that n greater than or equal to n. Then how could be the less number of states? Look at this, guys. Suppose NFA is having 5 states. The DFA may be equal or more. Do you agree for this? When NFA having 5 states, the DFA may have equal or more. Suppose it has 6 states. Do you agree for this one? When NFA is having 5 states, the DFA may have
Yes, sir.
equal or more. Okay, na? So 6 is possible. There is one concept, minimization of DFA. Using that concept, 6 states I reduced to 4. Are you following? NFA, some NFA I took that is having 5, and equivalent DFA, I have constructed this DFA, it is having 6 more states, and using the minimization of concept, I got the 4 states, and these two are equal, and these two are equal, means these two are equal. So when NFA is having n states, the DFA may have the same number, or it may have more, or it may have less also. I repeat, when NFA having n number of states, the DFA will have n, or more than n, or sometimes less than n, by using the minimization concept. And the maximum, this is 2 power n. Maximum 2 power n se zyada nahi. Okay, the DFA will not have more than the 2 power n states. Okay, so the same question, if I ask you the maximum number of states, instead of the number of states, if I ask you the maximum number of states, then definitely you should go to this answer, because already here I have mentioned that maximum. But here, what is the question? In general, how many states will be there? It may be more, it may be less, it may be equal, it may be 2 power n, but always not correct. So sometimes, so this. Okay, any doubt? Please ask me any doubt. If
So any
anybody
logical
has any
reason
doubt,
why
please
2
ask
raised
me.
to n is maximum?
Oh, you want the proof?
So I mean to say, is it obvious,
Means are you asking proof?
or is it involves some
Pardon?
relation?
No relation. Actually, there is a proof. Means are you asking how this is 2 power n, or what is question? Repeat the question.
So is it obvious that it is 2 raised to n, or is there a derivation or proof kind of thing?
Okay, there is a proof when a number of states in NF is n, and the maximum at any cost maximum you'll have 2 power n. There is a proof, and proof. Okay, I have not given to any student till now. So because we are going to objective, na? So it is not descriptive. That is the reason. Even very long back, I have tried this one. So right now I cannot give you. If you want, definitely I'll give you the proof in the next class. But just you go through this one once. You will have.
Can this be because power set of n has 2 raised to n members? So any of those subsets of states can be um,
When Q is
can be
equal
considered
to,
as one state.
suppose Q1, Q2, Q3. Okay. And in Q1, suppose in Q1 state, I'm taking input 0. Input 0 and 1. Miss, tell me how many ways I can define Q1 and 0? Hello, Miss. Are you following? The doubt who has asked me how it is to
Yes,
define.
sir.
In how many ways I can define Q1 and 0? One thing is nothing. Yes or no? For
Yes, sir.
Q1 state, I may not define, or I can define to itself, or I can go to Q2. So one is Q1, or the other one is Q2, or I can go to Q3. Ma'am, are you following?
Yes, sir. Or both Q2, Q3,
Or I can
Q1,
go to
Q2.
Q1, Q2. Or I can go to Q2, Q3. or I can go to Q1, that is what? Q1, Q3. Or what else? What else? Or I can go to Q1, Q2, Q3. Okay. Are you following? And the dead state. Okay. So how many states do you have? 1, 2, 3, 4, 5, 6, 7, 8. When we have 3 states in NFA, the maximum is 2 power 3. Or tell me, okay, you take this state. I'm talking about this state, this one. If Q1 and Q1, Q2 on 0, either you can remain in the same state, or you can go to this or this or this or this or this or any state. Any state you can go to itself or other 7 states. So that is the reason maximum 2Q. And don't think that, sir, I will take another state. I will go to this one. That is, I'm naming it as, suppose I'm taking it as some Q dash. Okay. That will be this state is Q dash. And I will go to this one. So from this, you can come to this. Or unnecessarily, if you define like this, what is the meaning of this one? If you take like this unnecessary states, you can take any number of states. Okay. These are unnecessary states. How can we go? In NFA, you can take any number of states, but in DFA, unnecessarily you cannot take. Are you following? In NFA, you can take any number of states, but in DFA, okay, when NFA is having 3 states, the maximum is 2 power n. That is 2 power 3. Those are this one. Or just tell me if you have any other doubt in this one, in the same. When Q1 input 0, we can go to dead state if it is undefined. Undefined means, I already told you, if it is undefined means 5. In DFA, you have to define. For that reason, you must go to a dead state. Dead state, I named it as 5. Are you following? This is dead. Or you can remain in the same, or you can go to Q2 or Q3, any one only. Out of this, any one only. So you have 8 options. So that is the reason maximum is 2 power n. Miss, say something.
Yes, I understood.
Okay. So take a note. The maximum number of states of a DFA equivalent to NFA of n states is 2 to the power of n. Copy this one. So I'll give you one more tricky question. Solve this. Okay. Listen. Before giving the question, I will explain the question first. Please respond immediately. Suppose there are 10 states in NFA. When you convert into DFA, how many maximum states you will get?
2 raised to 10.
Very good, maximum. If all these 10 states are non-final, then what about these 2 power 10s? Are those all non-final? Are those all final? Or all those final plus non-final? Some are final, some are non-final. What? Ma'am,
All final.
NFA we have 10 states and all these 10 are non-final. If I convert into DFA,
All
we
are
will have
final.
maximum 2 per 10. Are these 2 per 10 all are final, all are non-final, or some are final, some are non-final?
All non-final.
Very good. When you don't have the final states in when you don't have the final states in NFA, how do we get the final state in the DFA? All these are non-final only. Miss. See, if you go for this conversion, here Q2 is the final state. So the final states in the DFA are containing Q2. This is Q2 and this is Q2. That is the reason these two are the final. But when you don't have the final, example, if it is not having final, so can I take anyone final here? No, I cannot take anyone as final. You understand? So all are non-final. Now, if some are final and some are non-final, out of these 10, some are final, some are non-final, then also when we have 10 states, maximum will be always 2 per 10. So whatever these 2 per 10 are these all are non-final, or all these are final, or some are final, some are non-final? What about these 2 per 10?
Semi-final.
Yes, because okay, there will be some final and some non-final.
Some are final, some are
Final
non-final.
plus non-final. Okay, now the question is not this one. Okay, when NFA is having 10 states, you will have 2 per 10 maximum states in the DFA. Okay, now out of these 10, some are final, some are non-final. That is, 3 are final. If 3 are final, then 7 states will be non-final. Okay, now my question is, how many maximum final states will be there in DFA? Okay, that is the question. I didn't ask you what is the maximum number of states in the DFA. Everybody can answer this. That is 2 per 10. My question is, if 10 states are there in NFA, out of 10, if 3 are final, then maximum number of final states in the DFA is. Okay, take the question.
Two raised to 10 minus 2 raised to 7.
What is the answer?
So 2 raised to 10 minus 2 raised to 7.
So 128 steps.
Two raised to 10 minus 2 raised to 3. Sorry, 2 raised to 10 minus 2 raised to 7.
Now tell me your answer.
C.
Option C.
No, option D.
So option D.
Excellent, excellent. Okay, before I give you the options, you told me the answer in this question. Excellent. What's the good name?
Sabhargavi.
Final year or third year?
So
Okay,
third
good,
year.
excellent. Yes. So here the answer. Option is D. Okay, guys. Look at this. NFA is having 10 states. When NFA having 10 states, the DFA will have 2 power 10. These 2 power 10 are maximum. These maximum are final plus non-final. Altogether we have final. Altogether we have 2 power 10. Out of these 10, 7 are non-final. 7 are non-final. When you convert a 7 suppose forget about this 10 states NFA. There is NFA with 7 states. If I convert this NFA into DFA, you will get 2 power 7 states maximum. Okay, suppose there is NFA with 7 states. If we convert this 7 states NFA into DFA, we will have 2 power 7 maximum. When all these 7 are non-final, 2 power 7 will be non-final only because there is no final. Okay, in this. When we don't have any final states in NFA, so definitely we don't get a final state in DFA. So 7 are non-final, you will have 2% maximum. Now I will come back to this DFA. This is the DFA, and in this DFA, the total states are 2 power 10. So any automata, whether it is finite, whether it is NFA or DFA, the total states will be both final plus non-final. Final plus non-final. So if anybody has any doubt, that state is also will be there, and that state will be comes under non-final. Okay. So total states will be final plus non-final. So what is the total? What are the total states here? 2 power 10 in the DFA. So in this DFA, here NFA we have 10 states. Out of 10, 7 are non-final. From this 7 non-final, maximum you will have 2 power 7 non-final. So final plus 2 power 7 implies final equal to 2 power 10 minus 2 power 7. That is, we can take 2 power 7 common. How we can take? We can take this 2 cube into 2 power 7. 2 cube minus 1. What is 2 cube is 8. 8 minus 1, 7. So 7 into 2 power 7. So this is one method, and one more method is there, the different method. I will explain that. Just copy this first. Bhargavi, can you say how did, so I think you solved this way because you told me this one. Can you answer this in a different way? Means can you solve this in a different way?
So I'll try.
Tell me. So guys, copy this one. NFA is having 10, and 10 states NFA will be having 2 power 10 maximum states in DFA. And out of 10, 7 are non-final. From 7, you will get 2 power 7 maximum non-final. So any automata, this is the equation. So 2 power 10 is the total, and final we don't know, and 2 power 7 is the non-final. Then this is.
So one more method is that the first we can choose out of the 3 final states, we can choose 2 raised to 8 minus 1. So they definitely have to be there. 2 raised to 3
Good.
minus 1, sorry.
Good,
They
good,
have
good.
to be there.
Got it.
And
Got it. Got it. Explain. Have you taken any coaching or have you gone through any online classes?
No, sir. This is the first time I'm taking it.
Good, good. Copied? Hello guys, copied?
Yes, sir.
Okay.
Yes.
So the second method. We have 10 states in NFA. Let these three are final. These seven are non-final. Okay. These are states in NFA. NF is having 10 states. And let Q1, Q2, 3 are the final. Let these 3 are final and these 7 are non-final. From suppose, forget about this one, these 3. Suppose these 7 are the states. These 7 are the non-final states. And say, suppose there are only 7 states. So from these 7 states, if you convert into DFA, you will have 2 power 7 maximum. And these all 2 power 7 are non-final because out of these, no one is final. And forget about this one. I'm taking another or NFA. Let there are 3 states. And if you convert these 3 states into 3 states NFA into DFA, you will have 2 cube 2 power 3 maximum states. Out of these 2 power 3, if all these 3 are final, then what about these 2 power 3? All these are final or non-final, or some are final, some are non-final. Are you following? When all these 3, Q1, Q2, Q3 are final, if you convert into NFA, you will get 2 power 3 maximum. Out of 2 power 3, are these all final or all are non-final or some are final, some are non-final? Let us check. What are the 2 power 3 combinations from Q1, Q2, Q3? One combination is, one is Q1, the other one is Q2 and Q3 and Q1, Q2 and Q2, Q3 and Q1, Q3 and Q1, Q2, Q3. So 1, 2, 3, 4, 5, 6, 7. Actually 8 states. Na? What is the 8th state? The 8th state is dead state. Are you following? So out of these 3, if you convert into a DFA, you will have maximum 2 cube, and those 2 cube, those 8 states are these. Okay. Q1 is a final, Q2 is a final, this is final, this is final, final, but this is not a final. This is a non-final state. So from 3 states NFA, out of which all three are final, you will get 2 cube maximum. Out of these 2 cube, you will have 7 only the final states. So 2 cube, out of 2 cube, only 7 will be the final. Okay. Suppose Q1 is the final, and here the states you have 2 power 7, and one of them I'm taking Q4. If I club this Q1 and Q4, this result will be a final or will it be a non-final? Because as Q1 is final, this result will be a final. Similarly, if I club this Q1 and suppose this is one state in NFA, if I club this with this, then this is also final. Like this, in NFA, you have 2 power 7 non-final. From this 7 states, you will get 2 power 7 maximum non-final in the DFA, and from these 3 final states, you will have 2 cube minus 1 final states. So these 7, 2 cube minus 1 is this 7. With these 7 final states, if you mix with any of these 7 non-final, the result will be this 7 into 2 power 7 will be the final states. Are you following? If a club, any of these 2 power 7 states with this any of the 7 final states, then the result will be the final. So how many final states we have? 7 final. How many non-final we have? 2 power 7. Then 7 into 2 power 7, this result will be the all will be the final. So answer is 7 into 2 power 7. This is the one way. Or you can solve in this way. Total states equal to final plus non-final. Final we don't know. 7 2 power 7 is non-final. Then this is. Or from 3 we will get 7, and from 7 you will get 2 power 7, and 7 into 2 power 7, one is answer. Okay. Shall we go for next concept? Any doubt? Hello. Hello.
No, sir.
Okay. Next concept, equivalence between two automata. Equivalence between two automatas. Okay. Suppose I am taking two automatas, M and M dash, M and M dash are the two automatas. These two automatas are said to be equal if they accept the same set of strings. So take the notes. The two automatas are said to be equal. Next concept, equivalence between two automatas. The two automatas are said to be equal if they accept the same set of strings. If they accept the same set of strings. See, that means W1. If I take a string W1, if the first automata, here M and M dash are the two automatas. M and M dash are the two automatas. Okay. If first automata is accepting W1, then M dash also must accept. And one more string W2. If the second string is accepted by M dash, then M also must accept. If these two are equal, okay. And taking one more W3. If the first is not accepting, the second is also should not accept. And W4. If this the fourth string is not accepted, this M dash, and M also should not accept. So whatever the string you take, that string, if it is accepted by both or rejected by both, then we say the two automatas are equal. Okay, so take the notes. The two automatas are equal if they accept the same set of strings. The two automatas are equal if they accept the same set of strings. Okay, copied. The two automatas are said to be equal if they accept the same set of strings. Okay. Now tell me, are these two automatas are equal? Observe these two diagrams. Are these two automatas are equal? Are you there, guys? Are these two automatas are equal?
Yes, sir. No.
Why? Why
Because
no?
one is accepting alphabet is only different. This is 0, 1, this is AB.
Okay. Here, good. The first automata is accepting, the first automata is defined over set 0, 1. And the second automata is defined over set A, B. Okay, so the first automata accepts the some strings of zeros and ones, whereas the second automata accepts some strings of A and B. So how can we compare the strings of 0, 1 with the strings of A, B? So the strings of zeros and ones will never be equal to the strings of A and B. So here these two automatas never be equal. They are not equal because they have defined on different input symbols. So here, when you are comparing the two automatas are equal or not, the compulsory, the mandatory condition is they must be defined over same input alphabet. So I have dictated something. I told you what did I say? The two automatas are equal. I repeat, the two automatas are said to be equal if they accept the same set of strings. After that, you just write here, HERE. Here, the two automatas must be defined. The two automatas must be defined over same input alphabet. Okay. If the two automatas defined over same input alphabet only, then only they may be equal. Chance is there. When the inputs are different, they never be equal. Okay. Now, look at this. Are these two automatas equal? Are these two automatas equal? Yes, chance is there. Because the two automatas have defined on same input alphabet. Here the two automatas define over same input alphabet. Okay. Actually, there is no shortcut method to decide the two automatas are equal. I repeat, there is no shortcut method to decide the two automatas are equal. But if the two automatas are not equal, if they are unequal, definitely there will be a shortcut. What is the shortcut here? By looking at these two diagrams, when do we say the two automatas are equal? What if they are really equal? Whatever the string we take, example, if I take W1, either they both must accept or they both must reject. Okay. Otherwise, one string, suppose first is accepting and the second one is not accepting, or first is not accepting and second one is accepting, then they are not equal. If you can find at least one string, such that if that string is accepted by first one and the second one should not accept, or if the string is not accepted by first one and if the second one is accepting, then they are not equal. Okay, such a way, if you can find at least one string, then that is enough. But sir, I am trying with so many strings, sir. I have tried with 100 strings. W1, the both are accepting, and W2, both are not accepting. Again, W3, both are accepting. W4, both are accepting. Like this, I have verified for 100 strings, sir. In all these 100 strings, either they both are accepting or both are rejecting, sir. So then they are equal. No, you cannot say that. Even though you verified with 1 lakh of examples, examples, you cannot say that strongly. You cannot say strongly that these two are equal. But one string is enough, such that if that string is accepted by one and rejected by another one, they are unequal. So look at this. Can you find any such string? Can you say any such string which is accepted one and not accepted by another one?
Sir, BAAB.
BAAB. BAAB. So B, A, B. The first is not accepting. Second one, B, A, I repeat, B, A, B. Yes, second one is accepting. Yes, they are not equal. Such a string, one string is enough. And the simple string is triple A. Look at this triple A, guys. Triple A, one, second A, third A. First one is accepting. And first A, second A, third A. Second one is not accepting. One string is enough. Either this or this. Anyone is enough. Okay. So here triple A is accepted by first one, not by another one. So they are not equal. So one string is enough. So this is the shortcut method if they are unequal. Okay. Copy this. You take anyone, triple A or BAAB, whatever. Any doubt regarding this? Hello.
No, sir.
No, sir.
Take the next question. So did you copy? Did you all copy this one? Hello. Is anybody copying still? Okay. Next. Check whether the two automatons are equal or not. Take this one. Check whether the two automatons are equal or not. You just try to find a string such that that string is either accepted by first one and rejected by second one, or accept by second one and reject by first one. If you can find at least one string, then they are not equal. Okay, by looking at these two automatas. Say guys, hello. Hello. Nobody is giving the answer. Are they equal or not?
They are equal, sir.
Huh?
Equal.
So guys, here whatever the string you are taking, either that string is accepted by both or rejected by both. Example, I am taking A. The first automata here Q0. Q0 is accepting. Here Q0 is initial. And here Q3, Q0 is initial as well as final. Here Q3 is initial as well as final. Here it is accepting A. And here the second automata, it is also accepting A. And AB, it is going to Q1, not accepting. AB, it is going to Q4, not accepting. Like this, whatever the string you take, that string either accepted by both or rejected by both. Okay. So even though we try with 1 lakh of examples, I already told you, you cannot say strongly that they are equal. Okay. In this case, we will go to the procedure. The procedure is like this. There will be a combination like this, Q and Q dash. The pair Q comma Q dash. Q is corresponding to the first automata. Say this is M, and the M dash. The Q dash is corresponding to the second automata. This is M and this is M dash. Example. So Q is corresponding to the first, and again Q dash is corresponding to the second one. And in the both automatas, the inputs are same, A and B. In the first automata, if input A is given, where it is going. In the second automata, if input A is given, where it is going. That is the meaning of this one. Similarly, in the first automata, B is given where it is going. In the second automata, B is given where it is going. That's the meaning. Okay. So this is the pair. Every time, whether a string is accepted or not, to check, we must start from the initial states. Okay, for this reason. Okay, here, what is the initial state in the first automata? Q0 is initial. What is initial in the second automata? Q3 is initial. So, as we must start from the initial states, as Q0 and Q3 are the initial states in M and M dash, I have taken this Q0, Q3. Okay, so Q0, Q3 are the initial. Now, here, this is the input A. In Q0, if input A is given, where it is going. Similarly, in Q3, input A is given, where it is going. So look at this automata, these two automatas. In Q0, if input A is given, it is going to Q0 itself. And in Q3, if input A is given, it is going to Q3 itself. Okay, now we got this new pair. Okay, here we got the pair that is Q0, Q3. Q0, Q3. Whatever pair we get, just observe the two states in that pair. If both the states are final, or if both the states are non-final, then that combination is valid. Or one is final and the other one is non-final, or the first is non-final and the second one is final. If you get any combination like this, okay, one is final, other one is final, then we stop immediately and we will say they are not equal. Okay, but observe this. Here we got Q0 and Q3. What is Q0? Q0 is final. And what is Q3? Q3 is also final. So if both are final or both are non-final, that combination is okay. So here we got both are final. Now Q0 on input, this is input B. Okay, Q0 on B, it is going to Q1. And Q3 on B, it is going to Q4. So what are these Q1 and Q4? Q1 is non-final and Q4 is also non-final. If both are non-final or both are final, that combination is also a valid combination. Are you following? So here we have started from initial states Q0 and Q3, Q0 on A and Q3 on A. This is the combination. Q0 on B and Q3 on B, this is the combination. In this combination, in the first question, both are final. In the second, both are non-final. So this is a valid. And we start from only the initial states. And we continue this construction by taking the pairs, whatever we get newly. and the new pair here is Q0, Q3, and already we have defined for Q0, Q3, and the other new pair is Q1, Q4. So take the Q1, Q4. So don't take the permutation combinations. Okay, so like Q0, Q3, Q0, Q4, Q0, Q4, not like that. We will start from initial only, and we continue by taking whatever we will get new pair here. Now the new pair is Q1, Q4. Now observe this. In Q1, on input A, you can see it is going to Q2. Q1 on A, it is going to Q2. And Q4. Q4 on A, it is going to Q5. So I wrote this. Q1 on A, Q2, Q4 on A is Q5. What is Q2? Q2 is non-final. What is Q5? Q5 is also non-final. So both are non-final. As both are non-final, this is a valid combination. Okay, this is a valid combination. Next, we will check for input B. Q1 on input B. Q1 on input B is Q0. Q4 on input B is Q3. So here Q0 and Q3. Q0 and Q3 both are final. So okay, we will continue. Now what is the new pair we got here? The new pair is Q2, Q5. So take these two. Q2, Q5. Now Q2 on A. You can check this one. Q2 on A. It is coming to Q1. Q2 on A is Q1. Q5 on A. Q5 on A. It is going to Q6. Q6. Okay. What are these Q1 and Q6? Q1 is non-final. Q6 also non-final. So it is a valid combination. Now Q2, Q5 on B. Q2 on B is Q2. Q5 on B is Q5. So Q2, Q5 on B is Q2 and Q5. Q2 and Q5 both are non-final. Both are non-final. So it is a valid combination. Like this, how long shall we continue? How long shall we continue? We shall continue until we don't get any new pairs, or until we get any combination of final and non-final. Okay, here we have the new combination, that is Q1, Q6. So take the Q1, Q6. Q1, Q6. Now Q1 on A. What is Q1 on A? Q1 on A is Q2. Now Q6 on A. Q6 on A is Q5. You can see this one. Q6 on A, Q5. So Q2 and Q5. Q5 is non-final and Q2 is also non-final. Next, Q1, Q6 on B. Q1 on B is Q0. Q1 on B is Q0. You can see this one. Q1 on B is Q0. And Q6 on B. You can see this one. Q1, Q6 on B. It is coming to Q3. So Q0, Q3. So Q0, Q3 both are final. Q2, Q5 both are final, non-final. So what is the new combination here? Q2, Q5 already we defined. Q1 is already defined. So here no new combination. And in every combination, either both are final or both are non-final. Therefore, these two are equal. Do you understand? We didn't get any combination of final and non-final, and every pair we got the either both are final or both are non-final. So that is the reason these two automators are equal. Any doubt? So please copy. I think already you copied this one, these two automators diagrams. Okay. Then copy this solution. So after this, we will go for minimization of DFA. That is also important. And then we will go for construction of DFA. Construction of DFA is very important. Okay, don't miss it. You will see more interesting questions, and the questions which we have not seen, which you not have seen in your academics, because in academics they don't give you all questions, because there is a that is different approach. The semester approach is different and gate point of is different. So we will do more questions in concern of DFS, and after that I will tell you how to decide a language is regular or not. Suppose if a language is given something like this, a power m, b power n something. And by looking at this language, immediately within seconds, every one of you can say whether this is regular or not. If you go through the previous gate questions, almost in all year, they will give you some languages, L1 equal to something and then 2 equal to something, and like this. They'll ask you, which of the following is or regular, which of the following is context free. Like this, they will ask you. Okay, you copy this. Copied? Copied? Hello? Please respond, boys.
Yes, sir.
Yes, sir.
Yes, sir.
Anybody copying still? Okay. Next. Minimization of DFA. Okay. If a DFA is given with 5 states, the 5 states DFA we may reduce to 4, or we may reduce to 3, or we may reduce to 2, or we can reduce to 1, or we can reduce to 0. What do you say? If a DFA is given with 5 states, using the procedure, we may reduce to 4 states, or 3 states, or 2 states, or 1 state, or 0 states. How can we reduce? How can we eliminate all the states? Means vanishing the diagram. So no, you cannot delete all the states. So the minimum you can delete is up to 1, or itself it might be the minimized DFA. There is no guarantee that for every DFA you consider a minimal DFA. The DFA itself can be the minimal, or we may reduce. If we can reduce, how to reduce? That is the concept. Okay, the least number of a DFA is 1. Okay, now please copy this. Construct a minimal DFA. Construct a minimal DFA for the following DFA. So take this, copy this question. Construct a minimal DFA for the following DFA. This is the question. Q0 is the initial, Q2 is the final, and 0 and 1 are the inputs. So construct a minimal DFA for the following given DFA. Okay, here we have total. How many states we have here? Hello, how many states are there?
9.
Good. Q0 to Q8. Total Q0 to Q8. 9 states. Okay. Copy the question first. Copied? Okay. Now, while reducing the number of states, what is the first step? Starting step, very starting step. I think this topic is already complete to you. Hello? When you are minimizing the DFA, what is the very starting step, initial step?
Group final and non-final states together. Group final states together and group non-final states together.
Oh, separate final, non-final, simply. Anyone
Yes.
else? Anyone else? Is the same or anything else is there?
Removing unreachable states.
Good, excellent. The first step is delete unreachable states. That is the starting step. Delete unreachable states means those states cannot be reached from the initial. From initial, what is initial here? Q naught is the initial. From Q naught, whatever the states you cannot go, you cannot reach. Whatever the states, there is no path to reach them. You delete the state, those states first. So let us check whether we can reach all the states or not. Okay. Here, the total states are 9, Q0, Q1, Q2. These are the states, okay. Now, initial is Q0. Q0 on 0. Q0 on 0, it is going to Q1. Q0 on 1, it is going to Q5. Okay, so Q0 initial, it has to be there. Q1 we can reach, Q0 on 0. And Q5 also we can reach. Okay. Now, can we reach to Q2 state from Q0? Of course. Look at this one. In Q1, on 1, you can go to Q2. In Q1, if input 1 is given, you can go to Q2. So, from Q0, there is a path to reach Q2. So, that is the reason Q2 also can be reached. And Q0 on 0, you can go to Q6. Q0 on 0, you can go to Q6. So, Q6 also reachable. And how do we reach Q4? See, Q6, this one. Q6 on 1. Q6 on 1, you can go to Q4. And how can you reach Q7? Q7, you can see Q7 on 0, Q7. So, Q7 also reachable. How can we reach Q3? Q3 in Q8. In Q8. So I'm taking Q3 here. Q3, Q8. Look at this Q8. Q8 on 0. Q8 on 0. Q8 on 0, you can reach Q3. Then how can we reach Q8? Q8, okay, Q3 on 0, Q8. And Q3 on 1, Q5. And Q8 on 1, Q2. Okay, this one. But guys, look at this. From Q0, do you have any path to reach either Q3 or Q8? Of course, From Q3 we can come to Q5, from Q8 we can come to Q2, but from Q0, where is the path to reach either Q3 or Q8? If you reach Q3, then you can go to Q8, or if you reach Q8, you can go to Q3. But where is the path to reach either Q3 or Q8? So from Q0, we don't have any path to reach to Q3 or Q8. You can see, because here there is no where the output as Q3 except in Q8. Here only we have Q3, and Q8 we have only in Q3. So from Q3 you can reach Q8, and from Q8 you can reach Q3, but we cannot reach Q3 or Q8 from any other state. That is the reason either Q3 or Q8, these two cannot be reached. So we delete these two states. Okay, this is the way of finding. If a table is given, this is the, but when a diagram is given, within seconds you can identify the states which are reachable and which are not reachable. Okay, so first copy this one. Here the result of the first step. Step 1. Did you copy this one? Take step 1, delete unreachable states. Delete unreachable states. So you can copy this diagram if you want. Otherwise, just leave it. So Q0, Q1, Q2, Q4, Q5, Q6, Q7 are the states which we can reach from initial. As we cannot reach Q3 and Q8, so delete them. So I am deleting this because these two are not reachable. This is the lengthy procedure, but out of the procedures, this is the shortest procedure and easy procedure. Okay, but once you understand, for me to explain, it will take time. But if you really understand this one, so I will give you one more question. Those who can understand this one, the question whatever I'll give you in the next, you can do that within 1 minute, maximum 1 minute you can. Okay, so S1, the step 1. This is the result of next. So what is the first step? Delete unreachable states. Copy this one. And second step, the guy who told me the first step, it grouped the final, non-final. Some guy has told me that. So that is the next step. Separate final and non-final. Step 2. Separate final and non-final. Separate final and non-final state. This is step 2. The step 1 is delete unreachable states. Step 1 is delete unreachable states. And step 2 is separate final and non-final. You can easily identify out of these states, what are the final? Only Q2 is the final. The remaining all are non-final. So separate them. So step 2 is also easy. Separate final, non-final. Q2 is the final and the remaining all are non-final. We have separated. Okay. So please tell me what is the first step? Delete unreachable states. Okay. And second step, separate final, non-final. So copy this step 2 and S2. This one, step 2 and this S2. Okay, done. Next, step 3. Separate those states directly going to the final state. Separate the states which are directly going to the final state. Means whatever the states, either on input 0 or input 1, if they are directly going to the final state, separate them. Example, okay, this step, okay. Here, what is the final state? Q2 is the final. And in Q0 on input 1, I repeat, in Q0 on input 0, it is going to Q1. In Q0 on input 1, it is going to Q5. So Q0 is not directly going to Q2. You can see this diagram. See, in Q0 on input 0, it is going to Q1. On Q0 on input 1, it is going to Q5. But Q0 is not directly going to this final this final state. So whereas Q1 is directly going to the final state. So whatever the states directly going to the final and whatever the state not directly go to the final, we have to separate them. So for this, it is very easy. Q2 is the final. Where is Q2 as output? See in Q1 on input 1. See in Q5 on input 0. And Q7 on input 1. So wherever Q2 at the final state is having output as output. See Q5 on 0, it is Q2. Q7 on input 1, Q2. And Q1 on input 1 is Q2. So Q1 and Q5 and Q7. Q1 and Q5 and Q7. Q7 on input 1. Q5 on input 0. Q1 on input 1. These three states are directly going. Whereas Q0, Q4, Q6 are not directly going. So already we have separated the final state in the second step. So you keep this Q final state as a separate set. Out of these 6 states, Q0, Q4, Q6 are not directly going, whereas Q1, Q5, Q7 are directly going. So I have separated them. So I repeat this. The first step is delete unreachable states. The second step is separate final and non-final. Third step is those are directly going to the final. We have to separate them. So copy this S3, step 3 and S3. The rest, from step 4 onwards, we will continue in the next class. So do you know what is the next class? When is the next class? Hello? Hello?
So Friday,
Hello, please respond.
Friday, Saturday, right? Yes, sir.
When?
So every Friday and Saturday.
Oh, only Friday. Oh. So there is huge gap for the next class. Okay. So how much time you can wait? Now, can you wait or do you have any other class right now? Does anybody has any other class now?
No, sir.
No, sir.
No, sir.
No. If you have any other work, I'll leave you. Otherwise, shall I continue this or shall I leave you?
You can continue
Okay.
this topic. You can continue, sir.
Others are not.
Okay, sir, you can continue.
Please tell me if anybody has any other work.
You can continue, sir.
10 o'clock?
So we can continue.
Okay. Okay, please tell me anybody till now what we have done in this minimization. Tell me the 3 steps.
So first we deleted all the unreachable states from initial state. Then we separated the final and non-final states. and then we separated the states. Those are directly going to the final state, and those are not going to the final state.
Excellent. Good. Okay. So delete unreachable states, separate final and non-final, separate the states, those are directly going to the final. Next, step 4. Step 4. This is the main step. In each hold on. Step 4. In each set, for each pair of states, in each set, for each pair of states, check in each set for each pair of states, check whether they are 0 equivalent and also 1 equivalent or not. I wrote here. So copy this. In each set, for each pair of states, check whether they are 0 equivalent and 1 equivalent or not. Okay, what does it means? In step 3, this is the result of step 3. Okay, those are in the same set. Actually, this is one set. We have 3 sets. Another second set, and this is the third set. Those are in the same set. We have to check for each input. Inputs are here 0 and 1. Okay, so for input 0 and for input 1, we have to check pairwise, means those are in the same set. Example, in this first step, we have only Q2. So you cannot separate Q2 further because there is only one state. So leave the first set and come to the second set. In second set, Q0, Q4, Q6. So you have to check pairwise, that is Q0 and Q4, where you have to check whether they are 0 equivalent or not. If they are 0 equivalent, then check for 1. If they are both Q0 and Q4, if they are 0 equivalent and also 1 equivalent, then only we keep these 2 states in the same set. And similarly, you have to check Q0 and Q6 and also Q4 and Q6 pairwise. Okay, and you need not to check Q0 and Q1. You need not to check Q0 and Q1 already, as they are separated. Okay, already they are separated. Now come to this third set. You have to check Q1 and Q5 and Q1 and Q7 and Q5 and Q7 pairwise. Okay, pairwise for every input we have to check. So how to check that? We will do that.
So can you repeat why we don't have to check for Q0, Q4, and Q6?
1 second. I'll keep this for charging.
Because those are directly going to the final state. Therefore, one state is already different.
Okay, thank you.
Okay, because miss, these are the states in this set Q0, Q4, Q6, and what we are doing, we are separating the states. Okay, we are splitting the states from, actually this is the first very starting, we have these 9 states. So Q3 and Q8 are not reachable, so we have deleted them, and this is the result. And from this we separate the states like this, the final and non-final. Again from this, those are directly going and those are not directly going, like this we have separated. Now in Q0, Q4, Q6, okay, here this is Q0 is in this set and Q1 is in this set. Already Q0, Q1 are separated. Already these two are separated. Now out of these three, we have to check whether these three can be separated or not. Means for that you have to check Q0 and Q4, and also Q0 and Q6, and also Q4 and Q6. So those are in the same set. You have to verify for them only. As Q0 and Q1 already separated, you need not to check.
Yes, sir. Understood.
Okay, now in step 4 will comes from step 3, the result of step 3. So those are in the same set. Where is my pen? Okay, now the result of S4 I am writing here. S4. Okay, this is the first set. It is, as it is single, we cannot separate this. Okay, and these are the states in the second set. So what are they? Q0, Q4. So you have to check Q0 and Q4, and you have to check Q0 and Q6, and you have to check Q4 and Q6. You have to check this. Okay, pairwise, because in the second set, Q0, Q4, Q6, pairwise, Q0, Q4, Q0, Q6, Q4, Q6, whether they are 0 equivalent and also 1 equivalent or not. So that is what I am doing now. So Q0 and Q4, I am checking. Listen this carefully. If Q0 and Q4 are equivalent for 0, then you have to check for input 1 also. I repeat, Q0 and Q4, if they are equal for input 0, then you have to check for 1 also. If they are also 1 equal, then we write Q0 and Q4 in the same set. Okay, suppose Q0 and Q4 are 0 equal, but they are not equivalent for 1, then we will separate Q0 and Q4. And suppose Q0 and Q4 are not 0 equivalent, then you need not to check for 1. You will separate Q0 and Q4. Okay, don't waste the time. And they are not equivalent for 0. You need not to check for 1. Here only you separate Q0 and Q4. Do you understand this? Now I am checking for input 0 for the two states Q0 and Q4, whether they are equal or not. So look at this, Q0 and Q4 for input 0 I am checking. Now Q0 and Q4 for input 0. So Q0 on input 0, the output is Q1. Q4 on input 0, the output is Q7. I repeat, listen this carefully. So if I explain the classroom in the board, you can see at a time, but here I have to scroll front and back. That is the reason. So look, remember this one. We are checking Q0 and Q4 for input 0. Q0 on input 0, it is Q1. Q4 on input 0, it is Q7. The outputs are Q1 and Q7. Now we are at step 4. So step 4 will comes from step 3. Okay, we are checking Q0 and Q4 for input 0. Q0 on input 0, the output is Q1. Q4 on input 0, the output is Q7. Yes or no? Q0 and Q4. Here, one is Q1, the other one is Q7. The outputs are Q1, Q7. Now verify. Q1 and Q7, sorry for the disturbance. The outputs of Q0 and Q4 are Q1, Q7. Just identify where is Q1 and where is Q7. This is the longer procedure, but if you understand the concept, you can solve this very easily. Okay, as Q0 and Q4 in the same set, I am checking for Q0 and Q4 for input 0. For input 0, Q0 on input 0 is Q1. Q4 on input 0 is Q7. Now Q1 and Q7, the outputs of Q0 and Q4 for input 0 are Q1, Q7. Are these Q1 and Q7 in the same set or in different sets? Answer my question. Are the outputs of Q0 and Q4
Same.
for input 0,
Different
that is
set.
Q1 and Q7, are they in the same set? Same set. If they are in the same set, we say they are 0 equivalent. Okay. As they are 0 equivalent, we must check for input 1 also. As the outputs of Q0 and Q4 for input 0, they are in this set. For input 1 also, they need not be in the same set. For input 1, both the outputs of Q0 and Q4 must be, I repeat, for input 1, the outputs of Q0 and Q4 must be in the same set. That set can be this or this or this. Okay, as for input 0, they are in this set. It need not be for input 1 in the same set. They both the outputs of Q0 and Q4 for input 1 can be here, or can be here. Okay, now let us check. Now we are checking Q0 and Q4 for input 1. Okay, go back. Q0 on input 1. Hello, Q0 on input 1, what is the output? Q0 on input 1, Q5. Q4 on input 1, Q5. So Q0 on input 1, Q5. Q4 on input 1 also Q5. The outputs of Q0 and Q4 for input 1 are the same. So they are in the same statements will be same. Na? So the Q0 and Q4 are 0 equivalent and also 1 equivalent. So when Q0 and Q4 are 0 equivalent and also 1 equivalent, you cannot separate them. They will be in the same set. Now, as Q0 and Q4, Q6 in the same set, you have to check pairwise Q0, Q4, Q0, Q6, Q4, Q6. Now, already these two are equal. Then you check Q6 with any one of these two states only. You need not to check Q0 and Q6 and also Q4 and Q6. You check Q6 with any of the Q0 and Q4. I am checking Q0 and Q6. Or you can check Q4, Q6 also, because already these two states are belongs to the same family. You check the Q6, either it is belongs to the same family, means whether it is belongs to the same set or not. So that is the reason I took Q0 and Q6. Okay. Now Q0, Q6 for input 0. First you check the for input 0. Then if they are equal for input 0, then we will go for input 1. Okay. Q0 for input 0. Q0 for input 0. What is the output? Q1. Q6 for input 0. Output is Q6. Are you following, guys? We are checking Q0 and Q6 for input 0. Q0 on input 0, it is Q1. Q6, we are checking Q0 and Q6 for input 0. Q0 on 0, you can see it is Q1. Q6 on 0, Q6. One is Q1, which is here. The other output is Q6, which is here. Now tell me, are the outputs of Q0 and Q6 for input 0 are in the same set or in the separate sets? I repeat,
Separate
Q0
sets.
and Q6 for input 0. One is Q1, the other one is Q6. The outputs are they in the same set or in different sets?
Different sets.
When the outputs are in different sets, we say they are not equal. So Q0 and Q6 are not 0 equivalent. When they are not 0 equivalent, you need not to check for input 1. So separate Q0 and Q6 because they are not 0 equivalent. Do you understand this point? Hello? Do you understand? Okay,
Yes,
so Q0 and Q4 both are 0 equivalent, 1 equivalent. That is the reason I wrote in Q0 and Q4 in the same. But Q6 is not equal. That is the reason I have separated Q6. Now, so this second set is done. Now check for the third set. That is, first you check for Q1 and Q5. Q1 and Q5, first we will check for input 0. If they are equal for input 0, then we will go for input 1. Okay, so Q1 and Q5. Okay, Q1 and Q5. Q1 on 0. What is the output? Q6. Q5 on input 0. Q2. We are checking Q1 and Q5 for input 0. Q1 on input 0, it is Q6. And Q5 on input 0 is Q2. Okay, Q1 on input 0, it is Q6. Q5 on input 0, it is Q2. Hello, are you following? Q1 on input 0 is Q6 here, and Q5 on input 0 is Q2 is here. Now, are they 0 equivalent or not equal?
Not equivalent.
Good. Guys, if anybody has any confusion, we are checking Q1 and Q5 for input 0. Q1 on 0 is Q6, which is here, and Q5 on 0 is Q2, which is here. So one output is in this set and the other output is in this set. The outputs are not in the same set. If they are not in the same set, they are not equal, not equivalent. So Q1 and Q5 are not equivalent. Q1 and Q5 are not 0 equivalent. When they are not 0 equivalent, you need not to check for input 1. So just separate Q1 and Q5. Separate Q1 and Q5. Okay, I have separated. Okay, now these three in the same set. Already we have checked Q1 and Q5. So as Q1 and Q5 not equal, we have separated them. Okay, now check Q1 and Q7. Q1 and Q5 not equal, we have separated them. Now check Q1 and Q7. If Q1 and Q7 also not equal, remember, listen, if already Q1, Q5 are separated as they are not equal, now we are checking Q1 and Q7. If Q1 and Q7 also not equal, don't write all these three states separately. If Q1 and Q7 are not equal, then check Q5 and Q7. These two may be equal. Na? If these two are also not equal, then you have to separate all these three. Okay.
So can you repeat?
Yes, ma'am. Already Q1 and Q5 already we have separated them. Now we are checking Q1 and Q7. If Q1 and Q7 here, Q1 and Q5 are not equal, we have already separated them. Now we are checking Q1 and Q7. If Q1 and Q7 also not equal, don't separate all these three. When Q1 and Q7 are not equal, then check these two whether they are equal or not. If these two are equal, then you have to write Q5, Q7 in the same set. If these two are also not equal, then you write all of them separately. So simple. Now I am checking Q1, Q7. If they are not equal, then check Q5, Q7. That's it. I am checking Q1 and Q7. Okay, Q1 and Q7 for input 0. So you have to go back. Q1 and Q7. Q1 on input 0 is Q6. Q7 on input 0 also Q6. Listen, you can decide now only. Q1 on 0 is Q6. Q7 on 0 also Q6. The outputs are same. See, Q1 on 0 is Q6 and Q7 also Q7 on 0 is also Q6. So Q1 and Q7 both are 0 equivalent because the outputs are in the same set. When they are 0 equivalent, you have to check for input 1. When they are 0 equivalent, you have to check for input 1. Now we will check for input 1. Okay. Q1 and Q7, these two I am checking. Q1 and Q7 for input 1. Q1 on input 1, what is this? Q2. And Q7 on input 1. Q7 on input 1 also Q2. I repeat, we are checking Q1 and Q7 for input 1. Q1 on input 1 is Q2. Q7 on input 1 is also Q2. So the outputs of Q1 and Q7. Q1 on input 1, Q7 on input 1, Q2. So they are equal. Okay. So Q1 and Q7 are 0 equivalent and also 1 equivalent. So when they are 0 equivalent and 1 equivalent, we cannot separate Q1 and Q7. But already Q5 is separated. So this is the result of S4. Q2 already we have separated in the starting. And Q0, Q4 is one set, Q6 is separated. Q1 and Q7 is one set and Q5 is separated. So copy this, guys. One second, I will make this clear. So this is as I'm going front and back. Hello guys, as I'm going up and down. So it is somewhat, some of you maybe get confusion. So if you are understanding this concept, okay, otherwise if you want, I will repeat this. So this is the result of S4 and this, you please copy this one also. So copy this total. Okay. So whatever we did, whatever the procedure we did in S4, the same procedure will be continued S5, S6, S7, so on, until you can separate. Okay, so you keep on copying. I'll repeat the procedure. The starting step is delete unreachable states. Second, separate final and non-final. Third, those are directly going to the final. And fourth step, 0 equivalent and 1 equivalent. The same procedure, 0 equivalent and 1 equivalent will be continued. How long you can separate. Copied? Okay. Okay, if you copy this one, I'll give you one question. That question already I told you, you can solve within 1 minute. Maximum worst case 2 minutes. If you really understood this procedure. Hello, copied?
Yes, sir.
Okay. So this is S4. Now we are doing S5. S5. What is S5? So those are in the same set in S4. You have to check whether they are 0 equivalent and 1 equivalent or not. Q2 anyway single state, so keep as it is. Now Q0 and Q4 you check for input 0. When you are checking S5, you have to consider the S4. For input 0, I am checking Q0 and Q4. Q0 and Q4 for input 0. Okay, Q0 and Q4. Q0 and Q4 for input 0. Q0 on input 0 Q1. Q4 on input 0 is Q7. Remember this, guys. Q0 on input 0 is Q1. Q4 on input 0 is Q7. So the outputs are Q1 and Q7. The outputs are Q1 and Q7. Here I repeat. Q0 on input 0 is Q1. Q4 on input 0 is Q7. So the outputs of Q0 and Q4. Hello? Q0 on input 0 is Q1, Q4 on input 0 is Q7. So the outputs of Q0 and Q4 for input 0 are in the same set. If they are in the same set, they are 0 equivalent. So Q0 and Q4 are 0 equivalent. When they are 0 equivalent, you must check for the input 1. If they are not equal for input 1, you have to separate Q0 and Q4. Let us check Q0 and Q4 for input 1. Q0 and Q4 for input 1. Okay. Q0 for input 1 is Q5. Q4 on input 1 is also Q5. So Q0 and Q4. Q0 and Q4 for input 1. Q0 and input 1 Q5. Q4 on input 1 is also Q5. So the outputs of Q0 and Q4 for input 1 both are in the same set. Actually both are same. So there are both 0 equivalent and also 1 equivalent. So when both are 0 equivalent and 1 equivalent, we cannot separate the two states. So you have to write Q0 and Q4 in the same. And already Q6 is single, so you cannot separate further. Now check Q1 and Q7. Q1 and Q7. If they are 0 equivalent, then check for 1 equal. If they are not equal, then separate them. So I am checking Q1 and Q7. Q1 and Q7. Q1 and Q7. Q1 on input 0 is Q6. Q7 on input 0 is also Q6. I repeat, we are checking Q1 and Q7 for input 0. Q1 on input 0 is Q6. Q7 on input 0 is also Q6. So go back. Q1 on input 0 is Q6. Q7 on input 0 is also Q6. Therefore, Q1 and Q7 both are 0 equivalent. Then check for input 1. If for input 1 also equal, then we keep them. Otherwise, we'll separate. Now Q1 and Q7 for input 1. Q1 on input 1, Q2. Q7 on input 1, Q2. Q1 on input 1. Q1 on input 1 is Q2. Q7 on input 1 also Q2. So both the outputs of Q1 and Q7 are in the same set. Therefore, they are also 0 equivalent and 1 equivalent. So we cannot separate. And Q5 anyhow single. Now guys, look at this. Observe this S4 and S5. S4 and S5. Are these S4 and S5 same or not? Do you get any difference? Do you see any difference in S4 and S5?
No.
Okay.
No.
So S4 and S5 both are same. When you get the same as S5, then we stop this construction. So these are the only the minimized states. So this is 1, and this comma is in second, and this is third state, and again comma is fourth, and this is 5. So total 1, 2, 3, 4, 5 states. Whereas the given DFA we have 9 states, but now we got the 5 states. So when we reduced the number of states, we must reconstruct the DFA. Okay, na? As S4 and S5 are same, we stop the construction. Okay. Now, what is the initial state in the DFA? Q0 is the initial state. And what is the combination of initial year Q0 and Q4? So Q0 and Q4 will be the initial states. Okay. Initial state. Now, so Q0 and Q4, how to reconstruct this? Q0 and Q4, guys, Q0 on 0, Q1, Q4 on 0 is Q7. I repeat, we have the Q0 and Q4 as initial in the new DFA. So Q0 on 0 is Q1 and Q4 on 0 is Q7. So the combination is Q1, Q7. So that is the reason Q0 and Q4 on input 0, we are going to Q1, Q7. Of course, Q1, Q7 is one state. Next, like that, Q0, Q4 on input 1. Q0, Q4 on input 1. Q0 on input 1 is Q5. Q4 on input 1 is Q5. And Q5 is a single state. Okay, this one. And next, Q1, Q7 on input 0. It is going to Q6. Next, Q1, Q7 on input 1. Both are going to Q2. And Q5 input 0 is Q2. And Q5 input 0, input 1 is Q6. So this is the final DFA. So copy this one. First of all, you copy this part, then you can copy the diagram. So after this, I will give you one question. You solve that and I will leave the class.
So can you show that diagram?
చూడొస్తుంది Done? Hello?
Yes, sir.
Okay. Of course, this is final. This is final. Okay. Take this question. The number of states in the minimal DFA the number of states in the minimal DFA equivalent to the given DFA. The number of states in the minimal DFA equivalent to the given DFA is Just copy this. After copying, you can do this in 1 minute. First step, delete unreachable states. Second step, separate final, non-final. Third step, those are directly going to the final. And fourth step, A equivalent and B equivalent. Total we have 8 states and Q naught is the final year. And inputs are A and B.
So 3. A.
A, 3. Others? Hello? When the diagram is given, it is very easy when compared to the table. Okay. Anybody else? Answer? Hello?
Sir, three.
Only one girl is saying or else?
No, sir.
Boys, anybody?
Sir, 3.
Is good. 3 is the right answer. Okay. Now the first step. What is the first step? Please say. Anybody? Hello, please. Somebody say what is the first step?
Unreachable states.
Delete the unreachable states. Very good. So Q naught is initial. From Q naught, you can go to Q1, you can go to Q2, you can go to Q3. From initial Q naught, you can go to Q1, Q2, Q3. Can we reach any of these Q4, Q5, Q6, Q7 from initial? Do you have any path? Is there any direction to reach any of these 4? No, you cannot reach any of these states. So you delete this entire. Okay. If I delete them, what will be the remaining states? So these will be the remaining states. Q0, Q1, Q2, Q3. Okay. Now, after deleting unreachable states, what is the next step? Separate final and non-final. What is the final here? Q0 is the final. And Q1, Q2, Q3 are the non them. Separate the final and non-final. Okay. So separate. Q0 is the final and Q1, Q3 are the non-final. What is the third step? After separating final and non-final, what is the next step? Hello, please, everybody respond. First step is unreachable. Second one is delete unreachable.
Directly reachable final state.
Directly going to the final. So Q1, Q2, Q3. Out of Q1, Q2, Q3, is Q1 is directly going to the final? Yes, it is going to the final. Is Q3 is directly going? Yes, it is going to the final. Is Q2 is directly going to the final? Do you find any direct path to reach to Q0 from Q2? No. There is no path from Q2 to Q0. So Q2 cannot reach directly. So that is the reason separate Q1 and Q3 as they are directly going and Q2 is not directly going. Okay. This is the result of this one. After that, now guys, this is, so first step, unreachable. Second step, final, non-final. Third step, those are directly going to the final. One second. Okay, now step 4. Step 4. Anyhow, Q0 is the initial final, and we have separated. Now check Q1 and Q3. Q1 on input A, it is going to Q0. Q3 on input A, also Q0. So Q1 and Q3 both are going to Q0. So they are A equivalent. Now Q1, Q3 on B. Q1 on B, Q2. Q3 on B is also Q2. Q1 on B, Q2. Q3 on B also Q2. So Q1 and Q3 both are going to Q2 on input B. So Q1 and Q3 both are A equivalent and also B equivalent. And Q2 anyhow it is a single. So whenever S3 and S4, yes, both are same, then stop. So this is 1, 2, 3, 3 states. How simple it is. For me to explain it, it took so much of time. But once you understood this concept, you can easily answer the question. And however, when the diagram is given, it is more easy than the table. Okay? Any doubts? Hello?
No, sir.
Okay?
No, sir.
Shall I close this?
No.
What no? Okay? So we'll continue in the next class, maybe Friday. Or one more thing, can you attend 3 days in a week or only 2 days in a week? Are you there?
Yes, sir.
2 days a week.
Huh? One girl said something. I didn't get.
2 days a week is fine, sir.
Why, madam? You are getting tired, eh? No, actually today I took a long session. It's almost 3 hours. So because 2 days in a week, 4 hours. What? Your voice is not clear. No. Your voice is not at all. I didn't get you. Please, somebody else, please talk. What is saying? I didn't get you.
On Saturdays, maybe you can take little extra as you took today.
Oh. Means Saturday, Friday 2 hours, Saturday 3 hours, eh?
Yeah, Friday from 8 to 10 and Saturday you can extend like today you did.
Oh. Okay,
Because
as you
Saturday,
No. Why I'm saying is already this is October ending, so November, December, January, you have 3 months only. If I take 2 days in a week, and when can I complete this? Like this, okay?
We'll discuss, and if possible, like we can extend Saturdays or maybe Sunday, we can take 1 more hour.
Oh, okay then. Well, anyhow, at your convenience, if whatever you say, I'll follow.
Yes, thank you.
Thank you.
Thank you, sir.
Thank you, ma'am.
Thank you, sir.
Thank you, sir.
Thank you.